Good day and welcome once again to our YouTube channel. Thanks for subscribing to the channel, really appreciate you. Thanks for liking our content as well as sharing our pages. We really appreciate everything you have done. For those that are yet to subscribe to the channel, please kindly do so you can get easy notification every time we drop new comments or new content. Thank you very much. Today we quickly want to take a topic in chemistry, which is organic chemistry. So it is going to be an introduction to this aspect of chemistry. So we're having introduction to organic chemistry. So what is organic chemistry? What is organic chemistry? That is what we will be taking this very moment. What is organic chemistry? Now, when we talk about organic chemistry, we're actually talking about the chemistry of carbon compounds. That is what organic chemistry is about. Organic chemistry is the study or the chemistry of chemical carbon compounds that are occurring naturally. So let's put that down. Organic chemistry is the chemistry or the study of carbon compounds that are occurring naturally, That is what organic chemistry is all about. It is not talking about the oxides of carbon like the triazocarbonate and the rest of those, because those are actually inorganic chemistry. Those are inorganic parts of the chemistry, so it is not talking about those. So we are talking about the actual carbon compounds that are occurring naturally. So we want to look at, if we have to understand this better, we quickly need to talk about few characteristics of carbon that are going to be very, very particular to the inorganic aspect of chemistry. So let's quickly look at the characteristics of carbon compounds. Characteristics of carbon compounds. That is what we're taking right now. So we need to understand what the properties of carbon compounds are, why they are able to undergo this particular aspect of chemistry that we refer to as organic chemistry. So the characteristic properties of carbon compounds. The first one is that carbon atoms are capable of undergoing what we refer to as catenation. First one is that carbon atoms undergo catenation. So what is catenation? Catenation is a process whereby carbon compounds possess covalent bonds between their own atoms. Catenation is a phenomenon or a process that has carbon atoms possessing covalent bonds between its own atoms. So we have different types of those. We have those that are called the single bonds. We have those that are called the single bonds. We have those that are called, those ones are found exhibit something like this. We have, okay, let me do this so we get it better. Single bond. Then we have the double bonds, those ones are found looking like this. And we have the triple bonds. Those are seen looking like this. We have them looking like this. So every time we have bonds of carbon atoms having any of these bonds, in scenarios where we have something that looks like this is organic compound, or we have it looking like this, having two bonds between them. In a scenario where we have something that looks like this, we have it looking like this, bonding to another carbon atom, or we have it looking like this, bonding to another carbon atom, having triple bonds like this. All of these are referred to as carbon atoms, and they are organic compounds because they have these bonds between them. So we have the first one to be a single covalent bond, the second and the third one the double covalent bond, and the triple covalent bond. So that is the first characteristic property of the carbon atoms. Number 2 is that carbon uses 4 of its valence electrons to form covalent bonds. Yes, 2. Carbon uses 4 of its bonds, of its valence electrons, to form covalent bonds, with substances, like hydrogen gas or oxygen gas, nitrogen gas, as the case might be, and also with the halogens So these make up the second carbon characteristic. So it has the capability of using 4 of its valence electrons. We will get to understand those in a very short period from now. We understand why it uses 4 of its valence electrons to form bonds. So let us go to the third one, the third characteristic now. Number 3, carbon has its atom within a molecule arranged in different ways. Carbon undergoes isomerism. That is what we are saying. Carbon undergoes isomerism. So what is isomerism? Isomerism is a scenario or a phenomenon whereby a particular compound can have its structure arranged in different ways. Isomerism is a phenomenon of a compound having more than one structural formula. So let's quickly see an example. Let's have a carbon atom that has 5. A carbon compound that has 5 atoms, for example. So if we want to draw the structural formula for a carbon atom that has 5, naturally we should have it looking like this. carbon, 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 carbon. So this is our carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So they are all bonded together with this. We have the bond between them. We have all of the bonds found here between them. You can see the bonds between them. So this tells us that we have 5 carbon atoms and they are all bonded together. Yes, they will also have all of this, signifying that they have hydrogen atoms on them. Yes, that is how it will be, because we'll be having hydrogen, 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 hydrogen all around it. So this is an example of a carbon compound that has 5 carbon atoms, and this particular one is called a pentane. This particular compound is called a pentane. But we can have other carbon compounds that also have 5 structural 5 carbon atoms in their structure, but they will not be drawn as we have just done this. Let us quickly see other examples. This is another example, 1, 2, 3, and we have this and we have this, such that we'll be having, okay, let me make it clearer so we don't get confused. We're having this binding to these carbon atoms. So in this scenario, we are having this type of compound. So this particular compound is going to be named this way. Let's quickly put all the hydrogen compounds so we don't get lost. So if you count, you will notice that we have the same number of hydrogen compounds attached to them. And also here we're going to be having one hydrogen compound that is attached to this carbon. So here we are having our carbon atoms labeled 1. This is 2. This is 3. We have 4 and 5. So depending on how you want to name, you can go from here. So 1, 2, 3. If you go from here, that means we have on our second carbon atom, we have this is a functional group and this is another functional group. You get to understand what I mean by functional group as we explain further. And if you are choosing to count 1, 2, 3, what I'm saying is, if you decide to count as making this your number first carbon, carbon 1, carbon 2, carbon 3, that is how I have labeled. So that means on my carbon 2 here, I have all of this. Let me quickly put this so you understand what I'm saying. I have everything here. Everything here attached to my carbon 2, and also everything here is attached to my carbon 2. So that is what I'm saying. So carbon 1, carbon 2, carbon 3. On my carbon 2 now, I have this particular substance here attached to the carbon 2. Also this particular substance here attached to the carbon 2. So substances that have CH3, they are referred to as methyl. We'll get to understand those very soon. We'll get to understand that very soon. So CH3 is called methyl. So since we have on our carbon 2 here, we have one methyl here and we have another methyl here. That tells us that we're having 2 methyl substances or compounds on our carbon 2. So if we are naming this particular substance, it is going to be named as such. We'll be having 2,2 dimethyl, because we have 2 methyl. This is one methyl here and this is another methyl here. So and they are on carbon 2. That is why we are having them to be 2,2. The first one is on carbon 2, that is the first carbon. the first two, and the second one here also is on carbon 2. That is why we have the second two, and we have two methyls. That is why we are having di here to signify the number of methyl substances that we have. So we have 2,2-dimethyl. Then this is going to be our parent chain having 3 carbon compounds. So the name is going to be fully written as 2,2-dimethyl propane. 2,2-dimethyl propane. Now we are still working on carbon atoms with carbon compounds with 5 carbon atoms. That is what we are still working on. The first one we've talked about is pentene. We are trying to explain what isomerism is. We're trying to explain what isomerism that we have listed here, or that we have written as one of the characteristic properties of carbon compounds is. So we have listed the first one to be pentane. This is pentane here. And the second one that we are talking about now is the 2,2-dimethyl propane. Let us quickly see. We can still have another structure where we can have something that looks like this. We can still have carbon, 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 and here we have another carbon. So let us see. Okay, let me just put this here, and then I will put all of the bonds. This is one bond, this is another bond. Here I have another bond, here I have another bond. So let us quickly see. I have my hydrogen attached to all of this. Hydrogen is attached to all of this. So if we count, we still come across or have to get the same number of hydrogen atoms surrounding all of them. So we have hydrogen, hydrogen, hydrogen surrounding them all up. Now, this is another substance. Let me divide this so we don't get confused. This is another scenario where we have another substance named because it has carbon atoms of 5. So we have this to be our carbon 1, carbon 2, carbon 3, carbon 4, and this one up here is our carbon 5. And remember, like we listed earlier on, and I told us some substance that has CH3, like we have here, is also referred to as a methyl. Substance with CH3 is referred to as methyl. So what kind of compound is this? This one is going to be named, we're having it, if I'm counting from here, I've listed that we have carbon 1, 2, 3, 4. Look at this. I said we have carbon 1, 2, 3, 4, and this one is 5. But because this methyl is on this carbon atom here, then the numbering is going to change. So this automatically becomes our carbon 1, because we're going to count having the shortest possible number to our functional group. So this is our functional group. If I count from here, that is going to tell me that my methyl functional group is on carbon 3. Meanwhile, I could have counted from here to have my methyl functional group on carbon 2. If I count from here, it becomes carbon 1, carbon 2. So that is what the name of that substance is going to be. That means our numbering system is going to change. Our numbering system will change to this. We'll be having our numbering system to change now. So our numbering system is going to become carbon 1. Our numbering system will become carbon 1, carbon 2, carbon 3, carbon 4, and here we'll be having our the 5th carbon. So the numbering, the name of this substance is going to be 2-methyl butane, because butane is going to be this part here. This one here, 1, 2, 3, 4, is going to serve as our parent chain. So that is our parent chain, and on the parent chain here, which has 4 carbon compounds, that tells us that is a butane. So on the butane, the second carbon compound on the butane has the methyl functional group. So that is why it is called 2, showing the position of the methyl, and then butane. So if you look at it now, we're talking about isomerism. So that is what isomerism is about, showing different structural formula to a particular compound. So we have just used this as an example, showing the number of different possibility of the structural compound that we can have, a structural formula that we can have for a particular compound. So that is the third characteristic property of carbon. So let us go to the fourth property now. The fourth property of the carbon, and this is said that the carbon atom in a molecule can form continuous long chains as hexane, and it can also be a branched form as in 2-methyl pentane or the rest of those, or it can also form a ring as a cyclo compound or as an aromatic hydro compound like benzene. Let me quickly put that down so we'll understand it. We said that carbon atoms can form continuous straight chain. Can form continuous straight chains, e.g. as seen in hexane. For example, hexane is a carbon compound having hexane is a carbon compound, a 10 carbon atom compound having a straight chain, or it can also be branched and can also form branched chain. As an example of the ones that we saw just now, branched chain, e.g. in 2-methyl pentane, the substance that we drew just now, 2-methyl pentane, or okay, let me just give us the okay, let's continue. Or in form of a ring, as in the cyclo compounds like cyclohexane, or as aromatic hydro compounds, aromatic hydrocarbon like benzene. So these are possibilities of what carbon atoms can be. So let us quickly understand what this is saying. We can have a carbon atom to be in a continuous straight chain. So it can be in continuous straight chain, like example we just wrote about hexane here. Hexane is a 10 carbon compound. So this is what we are talking about. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have the bonds between them. Now. You can see we are trying to apply the bonds on them so we understand it better. So all around it now we'll be having different hydrogen atoms all around it. So it is assumed that we have hydrogen, and the rest of this. So this is an introductory session, introduction to organic chemistry. That is why we're trying to make it as clear as possible and as simple as possible. So that is what we'll be having there. So this is an example of what we refer to as the hexane. This is hexane. So you can also have it like a branched chain, where, because if you look at this now, all of the carbon atoms are on a straight line. All of them are on a straight line being bonded covalently to another carbon atom. but we can have it to be a branched chain. So this is an example of a straight chain hydrocarbon. This is an example of a straight chain hydrocarbon. So let us quickly see what we refer to as branched chain. So when we talk about branched chain, like the example that was given here, 2-methyl pentane, that means on the pentane, which is going to be the parent chain, we'll be having methyl on the second carbon atom. So let us quickly draw our pentane first. 1, 2, 3, 4, 5. Yes, let me divide this so we can make use of the other aspect of it for something else. So we have this. Let me see. Let's do this. Let's do this to make it much easier to manage. Let's do this because we still have two other compounds that we want to draw, so to make it easier. So let's see, we have pentane. 1, 2, 3, 4, 5. So each of them will be bonded to themselves covalently. So 1, 2, these carbon atoms are bonded to themselves, and then they have bonds to the hydrogen atoms that they all carry. So if you look at it now, that is what we are having. Now, this is what we refer to as pentane from the name that we have for this particular substance here. It says 2-methyl. So we have just drawn our parent chain. Now, if we are counting, we can choose to count from here, having this to be our carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So if we are counting like this, that means on our carbon atom number 2, this particular one here, that is carbon number 2, we will be having our methyl functional group. So that means this one here, this particular hydrogen here, will go out, will be substituted with a methyl functional group, such that we'll be having something that looks like this. We'll be having something that looks like this. On our methyl functional group there, we'll be having a C carbon atom, which is going to carry hydrogen atoms as well, because if you remember our second characteristic property, we said every carbon atom has the possibility of carrying 4 covalent bonds. So this one is also going to carry 4 covalent bonds because it is not going to be exceptional. So it is also carrying 4 bonds, such that we have hydrogen here, and hydrogen here. So this is a methyl functional group. Now this here is a methyl functional group that is on carbon 2. That is why it is named as such. That is why it is named 2-methyl pentane. Also, we can have other scenarios where we can have cyclohexane. Cyclohexane, for example, is a cyclo compound with 6 chains. So let us quickly do something like this. We have this. We have this. So this is an example of a cyclohexane, because every point here, every angle here has a carbon atom. You can see all of these points here, they have carbon atoms, and each of them, since at every junction here you have carbon atoms, they also have the. So what I'm saying is, in Okay, let me put it this way so it makes it much more understanding. Let me put it this way so we get to understand it better. So at every junction here, we have carbon atoms. At every junction here, we have carbon atoms. So if you see that every of these carbon atom now has two bonds. For this particular carbon atom, it has this bond here and this bond here. This particular one here also has this bond and this bond. This particular carbon atom also has this bond and this bond. So currently they are all having two covalent bonds attached to them. So that means they are left to carry two other bonds. So this is how the two other bonds will be attached to them. Such that each of them will now be having 6 bonds attached. Each of the carbon atoms will now be having 4 bonds attached to them. So if you see now, this is an example of a cyclohexane. This is the structure of cyclohexane. Let me just put the name somewhere here. Cyclohexane. So as you can see here written. Also it can be an aromatic hydrocarbon like a benzene. A benzene is a structural compound that has it is unsaturated. I'll get to explain that shortly. So it is a cyclo compound as well, and as it's being unsaturated, or they are very, very saturated, sorry to say. So this is what it looks like. We have it looking somewhat like what we have just drawn. Now we have hydrogen carbon atoms all around this place here. Now in between them we now have some double bonds. In between them we now have some double bonds like this, showing their structure very well. So each of the carbon atoms is currently carrying 3 bonds. So it is left to carry one more bond now, and these bonds will go this way. We have them going like this. So we now have hydrogen all around it. Hydrogen, 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 hydrogen. So this is what we refer to as a benzene compound. This is benzene. So these are the possible characteristics. We've talked about them. The first one we talked about is the fact that carbon atoms undergo catenation, as seen here. Now the carbon compounds undergo catenation. That is what we said as the first property of carbon atoms, that they undergo catenation. And number 2 is that they have the ability to form bonds, 4 bonds with covalent substances. And then number 3, we said it undergoes isomerism, as you can see here, whereby a particular compound undergoes different structural formula. And then the number 4th property is that it has the ability to form either straight chain hydrocarbons or branch chain hydrocarbons, or a cyclo compound, as the case is here in cyclohexane, or even an aromatic compound as we have just seen here. So this is, let me put it here, aromatic. So that is an example that we have just seen here. So that is that. Now let us quickly have an overview of what what chemistry, organic chemistry is about. So let's start from this. It is going to be an organogram. Organic chemistry. So let's have this. Let's have this. Let's say, okay, let me make this shorter so we don't take all of the space. All right. Can have this here. We'll be having the hydrocarbons, and here we'll be having the non-hydrocarbons. The non-hydrocarbons can further be divided into two, but that is not where we actually will be dwelling. So let us quickly see its own subdivisions. We can have the non-hydrocarbons to form acids, bases, as well as the neutral substances. Neutral. So that is that about the non-hydrocarbons. So let us talk about the hydrocarbons now. Hydrocarbons. So for the hydrocarbons, it is seen exhibiting this particular structure. So here we are having the aromatic compounds. Aromatic compounds, e.g., we have the benzene. We have benzene here, and on this other side here, we have what is called the aliphatic carbon compounds, the aliphatic hydrocarbon. That is what we have on this other side here. So we now have, under the aliphatic, we now have we have two branchings as well under the aliphatic. So it is seen this way. We have it shown this way. Let me put it here so we don't run out of space. Alright, so under the aliphatic now we have the cyclic cycloalkanes. We have the cyclic cycloalkanes. We have the cyclic cycloalkanes, and under the other side we have the alicyclic compounds. Alicyclic compounds. So under the alicyclic now, we also have other branchings. We have other branchings under the alicyclic compounds that will take us this way. We'll be having the saturated and the unsaturated. We'll be having the saturated and unsaturated hydrocarbon. Example is where we now have the alkanes, and on the other hand we can be having the unsaturated hydrocompound. Here we can be having unsaturated hydrocompounds, which can give us the two groups that we can have here to be. Example, we can now have the alkenes and the alkynes. So those are examples of this. This is for let's call it the foreview or the organogram of what hydrocarbon is about, of starting from it being an organic chemistry study. So that is what hydrocarbon. So we have this ranging from, starting from organic chemistry, we have it branching to hydrocarbons and non-hydrocarbons. Under the non-hydrocarbons, that is where we talk about acids, bases and salts, the neutral compounds, talking about the oxides of carbon and the rest of those. Then when we talk about hydrocarbon, we said it is the study of the hydrogen and carbon compounds alone. So it is broadly divided into two. We have the aromatic compounds like the benzene, and then the aliphatic compounds. Then the aliphatic compound is further divided into alicyclic and cycloalkanes, or the cyclic cycloalkanes. And then we said the alicyclic compound is divided further into the saturated and unsaturated hydrocarbons. Example of the saturated hydrocarbons, we have the alkanes, and for the unsaturated hydrocarbons we have the alkenes and alkynes. Let me just quickly give us the formulas for the general molecular formula for the alkane and alkyne. Here we have CnH2n plus 2. For alkanes we have it to be CnH2n, and for alkynes we have it to be CnH2n minus 2. So those are the formulas that we have for these substances. So we have the alkanes, the alkenes and the alkynes. So let us quickly talk about what hydrocarbons are, since that is what we actually want to talk about. So we'll just briefly talk about hydrocarbons now. Hydrocarbons. So what do we mean by hydrocarbon? Like we have said earlier on, it is just talking about the combination of hydrogen and carbon compounds. So hydrocarbons are compounds containing only hydrogen and carbon as the only element. They occur naturally as gas, coal, crude oil or petroleum. Compounds containing only hydrogen and carbon atoms, or compounds, as the only element. And they occur naturally. As seen in they occur naturally as gases, coal, we have them as crude oil as well, or petroleum. So that is what carbon compounds are. So their sources of hydrocarbon. The major sources of hydrocarbon. The major sources of hydrocarbon, number one, we have it as natural gas. That is what gives us the gas that we have. And number two, we have it in form of crude oil or petroleum. Crude oil or petroleum. And number three, we have it in form of coal. Those are the sources that we have our hydrocarbon as. So these are the major sources that we have for the hydrocarbons. So let us quickly see classification of hydrocarbons. I've listed them before, that we have hydrocarbon like we have here. Hydrocarbon is listed here, being divided into the aliphatic and the aromatic compound. And then under the aliphatic we have the alicyclic and the cyclic compound. Then we have the saturated and the unsaturated hydrocompounds. Those are the classifications of the hydrocarbons. So in our subsequent classes, we'll try as much as possible to pick each of these hydrocarbons one after the other. Particularly, we'll be talking about the saturated and the unsaturated hydrocarbons. We'll talk about the alkanes, the alkenes, the alkynes, and then we explain further on their general molecular formula, their structural formulas, talking about the characteristics of each of these classes. So please stay tuned for our next series on this particular topic. And please don't forget to subscribe to our channel. If you are yet to subscribe to our channel, please kindly do so. If you have subscribed, thanks for subscribing. Please like the comments, like the topic, share our pages and the rest of those to everybody around you, so as to inform them of what is happening here. Thank you very much for listening. God bless.